Little in the sense like whatever we have done so far as a part of, क्या है इसमें चक्कर? No issues, no concerns, or do you have any questions?
So I had questions, so I wrote it down in a piece of paper. So it's not with me right now. I will send you once I found it. Yeah.
Okay. No worries. Yeah. Continue. Okay. So okay, let me share my screen and let me know if you are able to see it.
Okay.
Okay. You are able to see my screen, right?
Yes.
Okay, fine. So today we'll be starting with our new topic, that is Spark. So first we need to understand like what is a Spark, because once we get to know what is Spark, then we'll definitely, because most of the things either we have to do with using Spark or PySpark. PySpark is same as we are doing with the Spark itself. The only difference is we are going to use most of the libraries from the Python. So when Spark with Python is PySpark. So that's why before moving to PySpark, we have to understand what is Spark, because
Once the first one gets started,
we understood the Spark, then because Spark can, if you know the Spark, then you can, you can write your code in Scala, you can write your code in Python, you can write your code in Java also, right? So all even R. So these languages are being supported by the Spark itself. So first we need to understand what is a Spark. So if I tell you, like Spark is basically, and it's again it's an it's an open source processing engine which mainly works for the wherever we have to process large scale distributed processing, and we have to do a lot of machine learning applications. We have to run huge amount of load, as we were doing as a part of Hadoop. The only difference that we see here is like within the Hadoop itself, basically Hadoop was It was disk oriented. Disk oriented means like it was having, in terms of speed, if I talk about, so the speed was less as compared to Spark, and it was around 10 to 100x less. So basically the speed of my Spark is 10 to 100 times faster as compared to Hadoop. And why? Because uh, so what happens is here, just to visualize you so that you should be able to understand it clearly. So let's suppose this was my file, right? My input file was there. So when I was processing this input file, I was doing some sort of, MapReduce, some mapper reducer functions I was applying on it. So when we were applying these mapper functions on this output file, so we have to store the output of this mapper and reducer onto the disk itself. Storing intermediate results, right? The results on disk itself. So if I'm just having only, let's say, one map task is there, and then this mapper's output will go to the reducer as input. So let's say this is my, again, reducer is there, and again the reducer is reading those input files. It's reading those input file from the mapper, and then my mappers, before it will go to the reducer, I've got lot of, shufflings and all. So multiple, when we are having, from source to target, how many number of transformations we were doing as a part of our, logic itself. So every time, let's say if I'm calling, let's say 10 times mapper is going to be called, like one mapper is calling another step is calling another step. So within each all those steps, every time when we are, even if we are computation is getting happened in the RAM itself, but when it did after computation, it is going to store the results on, even in the temporary file, it is going to store everything in the disk itself. So every time it has to read, write, read, write, read, write. So a lot of read and write operations are taking place. Because of this only, my Hadoop was, taking longer time to process. So when it goes to very huge and huge amount of data, so that's why it was consuming a lot of time. But within the Spark itself, what we are doing is, like, whenever we are just, let's say reading it, so in Spark, every processing until unless it is not getting completed. Like once from the input itself, it will read the data from the input, and until unless it is not going to write to my final output. So within these ones, the reading from the input and final writing to the output. Only within these ones, we were reading and writing the data to disk itself. Apart from this, whatever processing we are doing as a part of Spark 1, all are doing in memory processing. In memory. So that's why Spark is also called as in-memory processing. Like whatever intermediate results we are going to get, those all are going to be stored in the memory itself. So this switching from disk to first it is going to store in the disk, then intermediate, then it is reading, then writing, reading, writing. Those transformations are not going to be happen in case of Spark. So that's why Spark is almost 10 to 100 times faster. So this is Spark was initially like it's an open source because it was developed by Apache, and then they did it initially for their own project, but once they have done it, so they have made it free as open source. Now Spark, if I talk about its default interface or the language that it supports is Scala. So it is Spark has been written in Scala itself. So that's why the internal code is always going to be converted into Scala. So it supports multiple languages. Like we can write the code in Scala, we can write the code in Java, we can write the code in R as well as Python. So when we are doing it with the help of Python, then we call it as PySpark. But when we are doing it with the help of R, it is called as Sparkly R. Spark with Python. It is PySpark. And Spark with R. This is called as Sparkly R. Right? So basically, it's up to you, like in which language, or basically it also depends on the organization in which particular language they are using it. So, but right now, if you see in 85% of the organizations, or between 70 to 80%, most of the organizations they are really using this PySpark. But yeah, there are a lot of organizations too. Like within one organization also, we can have the like some of the tasks that we are doing, whether we are using PySpark or Scala also, Spark with Scala to build up a project. So it's all depends on organization to organization that how they are going to deal with it. So first thing, as I told you, if we talk about its features, so first thing, as I told you, it's in memory computation. There. Need to add it. Insert. Insert. I forgot like how we have to add a new cell to this. Generally, we used to have it like this. Here only. Insert new page.
What do you want to do?
I just wanted to insert a new page. I'm not getting that option here actually. Yeah. So but it is creating a new page, basically new file itself. We can have new pages within the same file itself. Document. Just giving me new one. Let's do it like this way. So let's talk about its features first, so that we should be able to understand what all features it is providing. So first is in memory computation. So whatever we are going to compute, it's all happening in the memory itself, right? So it's going to be same as we used to be in Hadoop. In Hadoop, it's going to be memory. Like processing is always going to happen in RAM, but intermediate results are used to be stored in the in this case itself. But in case of Spark, it is going to be in memory for that. Like whatever, even the internal computations or temporary data is going to be stored, so that is going to be stored in the RAM itself. So that's why it is faster. Another one is like fault tolerant is there. Like in Hadoop, we have got the concept of fault tolerant because of why we were having fault tolerant in. What do you mean by fault tolerant in Hadoop? If you remember. Yes. Why we are having this fault tolerance? How we were maintaining this fault tolerance in Hadoop? Shamila, any?
Yeah, I'm thinking. So in Hadoop fault tolerance,
How we were saying like my data is not, I am not going to lose my data in Hadoop because of
HDFS.
replications that we were having, right?
Yes.
And because of those replications, my processing was happening on one of them. But if one of them loses, so we can get the same data from another node manager, and then node manager performs the processing on that data. But here we are not maintaining any sort of those replications here itself. Replications here are only for the storage. For processing, like if it comes to the processing itself, so basically here what we does is, like when we are processing it, so how it is doing it. So how it does is, here for fault tolerance, basically we use, basically when we are storing the data, we are storing the data in either in RDD or in mainly in data frames, right? So data frames are basically, these are the the fault tolerance are there, or basically what we call them as, like if I'm creating a data frame, let's say I have created a data frame X, And when I'm just doing any sort of transformations on that data frame, so it is always going to create a new data frame. Same is the case with RDD. Like let's say I have loaded some data in one RDD, and when I'm applying creating a new RDD from that RDD, so every time when I'm doing any sort of operation on any RDD or data frame, it always creates a new data frame. In that way, like if I lost some data, so from that lineage, like from where it got started, I will be able to get the data again. So that's why it is called as fault tolerance, both my RDD as well as my data frame, or it is going to be data set. So there is little difference between RDD, data frame, and data set. So RDD is my we call it RDD are the those are the default or the basic data types that we are going to have as a part of our Spark. So internally, whatever we are going to start, everything is going to be the part of the RDD. So RDDs are, what is RDD? RDDs are resilient distributed data set. RDDs are resilient distributed, as the name is suggests, distributed data set. So resilient means like if some which cannot be destroyed, or if it got destroyed, so we can recreate it. And distributed, like it's going to be work from multiple machines, so we are going to process it or run it on the distributed or multiple machines. So that's why distributed data set is a set of data. That's why we refer. So it's a resilient distributed data set, and it's basically the what we call as the basic data structure that we are doing as a part of Spark. RDDs are fault tolerant, or we also call them as fault tolerant or immutable. Immutable means which are not mutable, like we are not changing them. So if I'm creating an RDD from an RDD, so a new RDD is going to be created. A new logical division or partition of that data is going to be created, so that whenever if any of the RDD is destroyed, so we can get it from the lineage itself, like from where it got started, so we can recreate it again. Let's suppose I have created an RDD let's say I've created some RDD R1, just to, let's say I'm reading some data into this R1. Then on top of it, I have written some, let's say map function on it to create an RDD R2. And then from R2, I have created some, let's say R3 RDD. So if in any case, so RDD1, RDD2, and RDD3, these three all are immutable. Immutable, like whenever I'm creating any RDD from, let's say I have read some data into R1, then from R2 I have applied, let's say I did some filtration, I have or I have added some function to it, so that modified my data, so that has created some RDD2. And from that RDD2, I have created, did some, let's say, action or some more transformation I did, and I have created an RDD3. So I did R1, R2, and R3. These three are, different data sets that we have created in the memory itself, right? So they are dependent on each other. Like R2 is dependent on R1, R3 is dependent on R2. But in memory, they are different objects that got created. And whenever we are creating any RDD, it is basically creating a new logical partition which is computed on different nodes of the cluster. So that's why same concept applies to data frames. The only difference between data frame and RDD is like RDD are my fundamental data structures, but on RDD they are already predefined. Functions are there, like transformations are there and actions are there. So basically two type of operations that we can perform and on any of the RDD. This is really very important to understand that we perform operations on RDD. One is my transformation and another one is the action. So transformations are the the transformations that we are applying on like I'm creating like loading the data to R1. This is one transformation. Then applying filter on it. This is going to be another transformation. So multiple transformations are there. So we have got in Spark we have got around 80 different 80 plus transformations and action functions are there which are already defined. But apart from this, if you want to create your own function, that can be done. Like we are having filter, we are having map function, we are having reduce by key, join by key, aggregate functions are there multiple. Then we are having print, show, take. There are n number of different functions are there, joins are there. So those are already predefined transformations and actions are there. So two types of operations, transformation can be there, actions can be there. So transformations are the like from RDD1 to RDD2, from RDD2 to RDD3. These we are creating, these are all transformation function. But action function is going to be the one where we are going to get the output. So like when we are like doing display, we are doing take functions or we are printing something. So those functions are going to be the action functions. So which basically triggers my DAG. So basically in Spark, we are having like everything is configured within the DAG itself. Like this DAG is my directed acyclic graph. It means where whatever the transformations and action functions that we are applying on an RDD, those are not going to create any sort of cycle within it. Because if cycle is going to be created, then it will go into the loop and it will going in an infinite loop. And if something goes in the infinite loop, it is never going to be completed, and this will never going to finish, and it will just waste our resources. So that's why everything that we are going to create as a part of Spark, that will work as a DAG, directed acyclic graph. Every action and transformation action, that it has to be finished somewhere itself. So cycle is not going to be great. That's why we say it acyclic, directed acyclic graph. There is no cycle in the graph itself. Understood? Clear? Any issues? Like, because RDD we have to understand.
Okay.
Yeah.
Yes.
And this how we are going to create these RDDs and all we'll see in practical, right? And like DataFrames, so we are going to use extensively. Like 99% of the time we are always going to use these DataFrames, because DataFrames are easy to understand. The only difference between RDD and DataFrames are there. Like DataFrames are in the form of row by column, like in the tabular format. So because of its tabular format, they are easy to understand, and a lot of more functions are there that we can apply, or optimization techniques that we can apply on top of the DataFrames. Those functions we cannot apply on RDD. So that's why DataFrames are more optimized data structure. Same is goes with the datasets also. So datasets are also we can say those are the super class for this RDDs. But the only difference between data frame and dataset is like my datasets somewhere like when it comes to some sort of in some cases data frames are not that much security constraints are not going to be applied on that. So that's why wherever there is some sort of data compatibility and security comes here, there we are going to use data sets. So basically, but in as I told you, 99% of the cases, it's going to be the data frames which are going to be used. There are some some cases where we have to use data sets, but in most of the cases we are going to use data frames itself. Like even I have not used data set for quite a long time. We are not using data sets at all because
So what is the difference between data frames and data set, you said?
as I told you, they are same, but the only difference comes when it is these security and compatibility issues are going to be there. So basically, my data sets, you can say those are mainly the strongly typed. They are and while my data frame is they doesn't follow any sort of they are untyped or data sets are there. And generally the data frames are in the form of row by column, but my data sets are in the form of row columnar formats. They are mainly the rows are there. But when it comes to the performance and how we are going to use easy use of the structured data sets, so there basically we have to come up with the data frames itself.
So in terms of compatibility and then security, which is better, data frames or data set?
Can you come again? What?
In terms of compatibility and then security, you said,
Yeah,
right?
yeah,
Which is better?
Data frames are better because data sets are going to be used. Mainly we use data sets generally when we are mainly going to work with Scala or Java, because there we have to need some sort of strong type safety and complex transformations are going to be required. So there we have to use data frames. And one more important the reason I got it, like because of these strong type safety, these data sets basically going to fail at the compile time only. But my data frames are only going to give you error at the point of runtime. So basically when we are compiling it, so generally we won't get any errors in case of data frame. So that's why, like, because my Java, Scala, they are all compile time languages are there, so they pick the errors at the time of compilation only. So in that case, wherever we need this type safety is our main requirement is there. So you want to pick the errors before moving to the runtime. Then we have to use data sets. But their use is, as I told you, it's limited because they are going to be when we are doing the these compatibility checks are going to be there. So we are basically adding one extra layer of security, and because of that, data set sometimes works slower as compared to my data frames, because they have got the overhead of serialization and deserialization. You know the concept of what is serialization and deserialization?
No.
So basically okay. So whenever we are moving our data over the network, so we have to serialize our data. Basically conversion of our data into binary format. That is serialization. And when we are getting data back to from that machine like 0101 form to back to our own form in which we want the data, that is deserialization. So this, because of serialization and deserialization overhead, it is slightly slower from the data frames itself. And again, like data frames gives you more flexibility in terms of optimizations. So when we are dealing with huge amount of like terabytes, petabytes of data. So what is our priority? Our priority is the optimization, because like this compatibility checks we can always do when we are processing, or when we are already within the code itself. And now with the new, like every time with this introduction of new libraries within the Spark itself, or within the PySpark itself, these compatibility checks are already been they have been taken care. So there are very less chances that our code is going to provide some sort of issues. Yeah, but if definitely issues can be there, but if issues comes, then we are here to fix those. But our main concern when we are dealing with large or big data is the performance, right? So that's why when it comes to the comparison, like which we have to use, so it's always the data frame which wins. Like we have to use the data frames itself instead of going for the data sets, right? Clear?
Yeah.
Okay. So that's why we basically use this these ones. And the next thing that we have to talk about is the it's fault tolerance, immutable, as I told you. Then as I told you, we have already discussed about the clusters. So yarn is a cluster that we use. So in Spark basically we can use yarn. Apart from this, like Spark, it always also provides its own cluster for managing the cluster, for doing cluster management. So it's Spark can provide its own cluster, or we can use yarn. In most 90% of the cases, we always use yarn. And there is another provider from the Apache itself. They also provided Mesos. This is another cluster manager is there, but its use is very limited. So in organizations, you will see always we are using yarn, right? Then another important point that we need to discuss here is which is very important to understand, is lazy evaluation. Lazy evaluation. You understand what, as the name specifies, lazy and evaluation. So lazy evaluation means is like whenever we are doing any sort of task. So my task is divided into whenever we are doing is like all the operations that we are doing on our data frame or data set or RDD, either those are going to be transformations or actions. Understood?
Mm-hmm.
So lazy evaluation means is my processing is not going to be start. Process will start, like actual processing will start only when action is triggered. Right? So what does it mean is, let's say I am reading this file, I am filtering this file, and in R3, I am displaying the result. Right? So this display function is my RD. It's an action function, right? So the sequence is like I got some read some file, then I did some filtration on it, and then after filtering, I'm just displaying the data. So my process is these are my files. So I'm reading some files into let's say RDD or data frame. Can be data frame also, DF, right? RDD or data frame into R1. Then I'm doing some sort of filtering logic or applying some map functions. So map functions can be, I'll show you like how many, these functions are there. So there are a lot many functions are there. Use, join, map, listing, group by, there are a number of transformations are there and action functions are there. So like we have got, like we are doing collect, we are doing, let's say, we are using take, we are displaying. So all these functions comes under this action functions. So until unless we are not going to hit this one, my actual data like files reading from this file is not going to create. Only what happens is there, as I told you, one DAG is going to be created. So here what happens is a DAG is going to be created, and this DAG is directed acyclic graph. Means is what? Let's say R1 to R2 to R3. So this is my graph, let's suppose. So I'm reading in R1, doing some transformation in R2, and then applying action function in R3. So once this action function is triggered, so this whole execution of this graph is going to be started. So if I'm not using any of the action function, so there is no processing is going to happen until unless I'm not going to hit any of the action functions. So action functions could be like, could be display, print, collect, or take. There are many, more functions are there. Let me show you some of the action transformation and action functions in Spark. So I think there are more than 80 functions are there. So see, like we have two types of transformations are also there. We'll discuss all this, narrow and wide. Narrow transformation, basically wherever we are not moving our data, like no shuffling is happening. Those are narrow transformations, and in wide transformations shuffling happens. So like map, filter, flat map, union, select, with column. These are all narrow transformations. Then we have got like wide transformations where we are like my data can be in different partitions. So when we are grouping by या joining, reduce by की repartition कर रहे हैं, distinct कर रहे हैं. So because we have to do the distinct, so it will check all the partitions, and then it will show you, okay, these are the distinct keys are there, right? So that's why wherever the shuffling is going to be there, those are wide transformations. Wherever we don't have these shufflings, it's called narrow transformation. This is another important question generally can be asked. Now action functions. So whenever actions are triggered, options that trigger the computation. So until unless we are not going to make any action function call, my execution is not going to be triggered. So like it's going to be collect, count, show, take, write, reduce. These are all action functions. So there are n number of more functions are there. Totally, I think we are having around 40, total 80 different transformation. These functions are there within the Spark itself. Understood? Then another point.
Yes.
Like, yeah. We are also having like cache and persistence. If you know this concept, what is cache?
The temporary storage data.
Cache and persistence.
Yes.
So basically, cache is the it's basically the RAM, the fastest memory available. So all the latest computed results are always remains in my cache, right? So, but it is quite expensive, so that's why we cannot have like generally cache we used to have on very good systems. It can be 4 MB, it can be 8 MB, 16 MB, likewise. Then it's the persistence. So persistence is basically the storage, like how we are going to store the data onto the like whether we are storing the results in cache or persistent means storage, basically the disk itself. So disk can be like even persistence has got multiple options can be there. It can be in memory itself. So it's the same like persistence means here we are talking about the RAM as well as disk. So here it can be RAM plus disk. Both can be there. This is also RAM, but this is some fastest RAM is there. This is very high speed RAM. Cache is basically it's a high speed RAM, but its size is quite small. So if that we can store the data in the cache itself, that is fine. But sometimes if the data set is quite large, so it's not feasible to have that one in the cache itself. So we can do it on the RAM itself. So within this we can have like memory only. So it is called RAM. So persistent can be memory only, disk only. So when we are only storing onto the disk, or it can be both RAM and memory. So some can be on the RAM and something can be on the disk. So it's all depends. Like so we can specify like whether we have to persist our data or if we are using persist. So where we have to persist in the RAM only, in the disk only, RAM and disk both, right?
Okay.
Or if we want to do some sort of cache, so we can just write like df.cache. So like if I have to do like my data frame should store its data in the cache itself, so I can do it df.cache, right? And then to apply this cache, I can just apply any of the action functions, right? You can call collect, you can call like display, any function we can call as to basically initiate this functions. And then after this, as I told you, like as we are going to use DataFrames, so DataFrames offer you a lot of inbuilt memory optimization techniques that are being offered by the DataFrames. And the last point I can say is like this also support like Spark supports SQL. Like if we have to perform any sort of operations using SQL also, so we can directly call these SQLs within this. So what we have done is like so far, like Spark is it's a general purpose engine where we are going to process the data from the in-memory, and this is fault tolerant. Distributed processing engine is there, which allows for process data efficiently in a distributed fashion. And the applications which are running on the Spark, they are almost 100 times faster as compared to traditional systems or Hadoop, right?
Mm-hmm.
And we can, like, if we have to process the data using Spark, so we can use Hadoop. From the Hadoop itself, we can process the data, Hadoop HDFS. Then if we are having any sort of, any storage from the cloud itself, like AWS S3, we can use Databricks, DBFS, or Catalog. We can use Azure Blob Storage, or many other file systems, like wherever any kind of file it supports, so it supports n number of files. So there is no such thing that as I told you, if you remember, like Hadoop is only meant for processing the batch data, right? It doesn't support to process the streaming or real-time data, but Spark supports both batch as well as streaming data. So streaming data we can process it, let's say multiple different technologies are there, like we can use Kafka, we can use Kinesis, we can use even Spark streaming is there. Now we have got in Hadoop in this Databricks, we have got this autoloader is also there, which supports both like batch as well as streaming. So we'll discuss all these things, but just to give you the gist, like we can do any sort of such transformations, any processing onto this using Spark. And also Spark, it has got a lot of inbuilt libraries are there which can work for machine learning graph libraries are there. We can work with n number of different connectors are available, which can store the data from diverse data sources. Like if we have to store the data from the get the data from the NoSQL databases like MongoDB, Cassandra, CouchDB. There are n number of so it supports all kind of data connectors are available which can support it. So as I told you, like language support, so it supports Python, it supports Java, it supports Scala, it supports R, right? So multiple languages it supports. Now let me get we used to have just one command was there which inserts new. Oh, I think I got it now. Let me.
You can duplicate it, right?
I think here we generally used to get one more window where this shows like how many more windows are there. Like I'm having previous slides also. Open this one. But I'm using it after a quite long, so maybe I've forgotten
Yeah.
to use it. If you see here, we are multiple, and layout. We used to get line color. This is for exportation. This is used. Wait, let me just do. Let me Google it. View page. Add new page. View. Page and yes. Now, okay. This was hidden actually. Now we can just go and new page. I remember it, but right. So now let's talk about its architecture. Okay. So let's suppose we have got this one. So again, as we have got, the concept of Hadoop architecture, it was a client server architecture, or you can say master slave architecture, right? So in the Spark architecture also is the same. It's a this is same as client server, or you can say master slave architecture is there. So here we have got one thing that is called driver program, which is act as my master, right? And then here these are all worker nodes. Where my actual processing is going to happen. Similar way as we had. And within this, we have got this cluster management or cluster manager, which takes care of all the resources onto the system itself. So within this driver program, we are also having one more internal program which works. Which is also called as the the starting point of my Spark program is we can call it as Spark context. Spark context So this is my Spark context. And so this Spark context is within the that driver program itself. And within each of the data nodes, we have got executor. There's one more, call it as executor. Here we can have executor. Okay, so these executors basically have all the resources, like in the form of cache, memory. All these things are going to be part of executor. So this is how it works. And we have got these work connect with each other like this. This also connect with this, and this manager also connects with all the both the executors. So this driver program is going to be the one, but this worker nodes can be any number of worker nodes. So here we have just shown you just two worker nodes, and on each worker node there can be more than one executor which are running the similar way. Like executors, you can just think about as we have got the node managers, right? And worker nodes are the data nodes. So on each of the worker node there can be multiple executors. You can take it as the app masters. So multiple app masters can be there based on the how many number of applications are running, and these two can also talk to each other, like they can connect with each other. So this is the architecture. So Spark works basically in the form of this master slave architecture, where master is called as the driver program and the slaves are called as the workers. So whenever we are going to run in any of these Spark application, so driver creates this Spark context object, which is the entry point of my application. And all the operations means, what are the operations in Spark we are having? Like either those can be transformations or actions. All those actions or transformations, or we call as operations, they are all going to be executed on the worker nodes. And all the resources are being managed by this, cluster manager itself. So here again, we are having, like Spark job is there, which is getting created whenever a request is going to become from a client. So it will come to the driver program, and then driver program, creates that context object, which becomes the entry point for that my job object. So whatever the the resources are required, that are being provided by the cluster manager to all the worker nodes. Once this task is getting executed, so these worker nodes update everything back to the client program, because the result comes back to the driver program. And once this is done, so all these executors basically release its memory itself, right? So now we are going to have this. Then, as I told you, this this cluster manager, what it is doing. So basically, as I told you, the cluster manager can be, it can be standalone, which was it's Spark's own cluster. This is very, simple cluster manager is there, which is inbuilt included in the Spark itself. But this is mainly, it's only for the easy, very easy task, or when you are doing it for your, let's say, testing purpose or development purpose. It only, works on very small set of clusters. But it works. Another one is, as I told you, Apache has provided another cluster which is called Apache MLlib is there. Give it here. Cluster manager. First, the standalone, which is Spark's standalone cluster. Then we have got Apache MLlib. This is also, the cluster manager which can run, using Hadoop, MapReduce, and Spark applications. Then third one, which is the most important, is Yarn. This is the the same cluster that we are using in the Hadoop itself. So it's Hadoop Yarn, which is the resource manager as we had in Hadoop 2.0, and this is the one which is mostly getting used. Apart from this, recently, a few years back, Kubernetes has also, introduced its own, cluster. But it mainly works on when we are working on the, this. It's mainly used for, containerized applications. Wherever, again, this Kubernetes is also an open source, deployment services are there, which is mainly used for managing all the containerized applications. So we can use any of them, but if you see, 90% of the time, this is the Yarn which we are using. And wherever we have to use the containerized deployment that we have to use, so there we can also use this Kubernetes. Okay. Cluster manager is there. Okay, it's done.
So Kubernetes, we need to we need to learn the KQL, right?
Yeah, we have to just configure all those things. It's all configurable. Like we have to download and install it on our machine, and then we are able to do some sort. We have to do some sort of configurations, settings, and it is ready to be done. But if we are just, let's say, if we are going to use, let's say any of the, unified platforms like Databricks, so there you don't need to, install anything. It is all being already, given. But if you have,
Integrated. Okay.
if you
So
have to
no.
work on, let's say you have to, if you have to do some sort of, installation on your, even on your Windows machine, you can do it. So there are some things like first we have to use Spark shell, then we have to use setup winutils.exe and then install Spark, and then you will be able to do it on your machine also, on your local machine itself. So there when we are using this local machine, so this generally going to be used as a CLI, command line interface, but we can also use its UI also, because by default it runs on 4040. So by default it's 4040, where we can use Spark and see it, like how it works. Now this basically also support a lot of core capabilities, or the what we call as it has got its own ecosystem is there. Spark's ecosystem. Most of the things we have already talked about, but let me just give you brief about that also, which is called as Spark's ecosystem. So within the Spark ecosystem, we are having Spark SQL is there. Like if apart from like using Scala, Java, or Python, that is mainly used for processing our doing transformations. But apart from this, if you have to use, like if you are not familiar with these languages and your workload is only the structured data sets are there, so for that you can also use Spark SQL. Spark SQL, which is totally the SQL language we can use to process our data sets. So for that we have to just call this Spark SQL, and even in Databricks also we are having this facility. Then if my data is coming out to be as streaming data, so to process my real-time data, I can also use Spark streaming. This is another library that we can use. Then another one that we can use is within the Spark itself called MLlib. That is machine learning library. Like whenever we have to do any sort of machine learning models we have to implement in our code, or if you have to do some sort of machine learning tasks, so there you can use this MLlib. So these are already predefined libraries are there that I'm talking about. Then one more library that you can use is Spark Graph, and for that we are having GraphX. So this is the library that we can use whenever we are we have to use any sort of networking, where a lot of networking is required. Graph related things we have to work upon. So these things are these are all we can use on top of the Spark core. In the core itself, as I told you, we are having R, Python, Scala, Java. These are all supported within the core itself. So what as I told you, we have one thing which is called as the Spark context. So this is called as the entry point of my Spark. But now instead of, because Spark context, what it does, like for each job we have to create different Spark context we have to create. And Spark context is this was also have some issue with the, like it was session scope. Like whenever we are deleting the session, so generally its history got deleted, we have to do it start from the starting itself. But then we have come up with another concept from Spark version after 2.0. Now we are having Spark 4.0, but after Spark 2.0, before Spark 2.0 we were using this Spark context itself, but now we are using Spark session. So whenever now this Spark session is the entry point of my Spark application or development whenever I'm using any of the RDD data frame or dataset is there. So now it's the Spark object that is being created. Previously it was Spark context. Now we are creating this Spark session. So automatically this is when I'm going to create any of the RDD data frame or dataset, and I'm doing any sort of whenever I'm calling any sort of action function. So automatically this Spark session got created. Clear? Any questions, any queries, whatsoever we have discussed so far, please let me know.
Oh, okay. I'm good.
Okay, so now I'm going to show you the how it looks when we are going to. You have to down. You don't need to download, but you need to register on Databricks itself. So I just did it because I am already having Databricks instance availability on with me. So this is, you see, this is the Databricks UI. So when you are going to register, now what you need to do is, it's quite simple. You can go to Google and you have to just say Databricks free edition. It's free of free is there, because if it's up to you, like if you want, because now previously what we used to have is this Databricks community edition. In community edition we doesn't have all the features, but in this now what they did is, like in Databricks free edition, if you see this free edition is there, we can get all the features, but they have got some limited usage is there. But still we are having all this Unity catalog and all. Previously we don't have those facilities in community edition, so we have to we were not able to see it. But it's all depends, like once your this free edition is done, it generally for two months, and if you are using it in a controlled way, then I think for an year you don't have to pay anything, right? Because they give you some sort of free free credits that you get with each free edition. So this is my free edition that I have just created today itself. So if you go, if you see, if I go to home, so once you let me, I was just telling you. So once you are going to click on this, right, free edition, it will ask just for the sign up, right? Just sign it up, and then once you log in, so you will come up with this UI. This is my home page, right? So within this home page, you see, let home is there, then learning is there, then workspace is there. So workspace is the where we have everything that we have to do. So workspace is going to be my place where whenever I'm going to create any sort of notebooks, anything I have to do, those are going to be the part of my workspace. Within my workspace, so whatever the ID that you are going to use, within that ID you can create the that user is going to be created. Within that user, I have just created my let's say my files, one folder which contains other things. So here I just within this I created one notebook also, right? So this is how we can do it. It's quite simple actually. So once you're done with it, just play with it whatever you want, because it's free. So and this is how we can, like within our our folder also, or apart from this, if we want to create anything, if you don't want to create within the user itself, I can create anything in the shared folder also. Within the repos also I can create. So based on my requirement, we can create more number of folder itself. Like click on this, so it will show you like create. If you go to the right side, if you see, you can create folder, you can create git folder, you can create node, and also create files. If you want to create some query, dashboard, there are a lot of things that we can do it. We can create even ETL pipeline. We'll see it later. But yeah, just for the information, like we can do most of the things. And within this recent one, whatever you have done so far, like recently, those things will be there, because what I did is like I have created this catalog with the name my catalog. Within this my I created schema, and within this schema that you can more number of tables you can create, views you can create, even you can create different folders. Let me go into this catalog. So within this catalog, I have got my catalog. Within my catalog, I have got my schema is there, and here also I am having my files. Right. So right now I don't have any files. This is just the folder. So you can create any folder, and if you want to bring any like upload, you want to upload any file, just click on this, and from here itself, if you want to select some files or folders, you can do that. Let me just say revenue estimate. This is an Excel file. I've created this. So this file has been added to my folder, and now you will see this file is there. See, this file is there. Just 5 seconds ago, this got added, right? So this way we can just create multiple folders, files. So what is this catalog is all about? So catalog is basically it's a centralized repository where we can manage or do lot of governance activities, like whatever tables, files I'm creating. If I have to give the permission to whom we can want that this file should be available. So based on that, like I can go to the permissions, I can add or revoke, like grant permissions, revoke permissions. I can just tell like what sort of access I have to give to this particular person. So those governance tools, like whether RBACs, like role access controls, I have to specify on all the like whether at the catalog level, schema level, or file level or table level. It all depends on me. Like if I'm giving at the catalog level and schema level, so then all the files within that catalog, those will be accessible by that. And what kind of permissions I have granted to that particular person, like whether those are going to be read permissions or edit permissions. So if it is read only, then they cannot make any changes to that particular file or table or view, whatever it is. But if I've given manage permissions, so manage generally it's all read, write, or access permissions are there. So if you want to modify that particular tables, you will be able to identify. You can delete that, and then on top of it, apart from manage, there is one super user which is called the admin is there. So admin is generally the one who creates that schema or the catalog. So they have got full permissions. Like if they want, they can delete it also, right?
Okay.
Permissions we generally specify. So that's why this Unity catalog is one of the the main or the today's world. This is one of the powerful thing which has been introduced within the Databricks itself, right? So a lot of things, and let me just give you the importance of. You can just go through it. Yes. Importance of Unity catalog. Also within Unity catalog, this also gives a lot of other advantages. So as I told you, it's a centralized access control. Then automated data lineage is there, like because whenever we are creating a table, so we also get to know where like this file is coming from where, this table is coming from where. So we got this, right now I don't have any table within this, but let me try to show you from my data itself, because here thing is these are all given. So, At later point of time, we are going to do all those things. But just to give you a brief about this, we have got, whenever we are creating any table and that table is dependent on some other table, so it always gives us that lineage, like what is its source and what is its target. Like if a particular table is coming from some data source, then transformations, then it is some source for another table. So those things we can get it from there itself, right? So similarly, we can do that, right? So yeah, apart from this, like this is another thing that we'll do later, but just for your understanding, like here we can create different jobs and pipelines, data pipelines, right? So we are, like, say I have created a notebook and I want to run that book. So here I can create the job. I can create the job. I can, within that job I can create the ingestion pipeline or ETL pipeline, or I can create the workflows also to schedule that job, like when that job is going to work, what is its frequency, those kind of things we can do it. And all those things will be visible here itself, like how many jobs are running, which got failed, and if those got failed, we can get to know all those things, right? Then compute. This is another important part where we have to create the, our compute in the sense, like we are going to create the cluster itself. Here in free edition, there is one, the boy is there, like we can create only one cluster at a time. Like if I have to create another cluster, so I have to first, disable this, delete this cluster, and then I can create it, right? So this is how I can do it, right? So here it's asking for the permissions. Right now I am the owner, and if I have to give this, let's say admin can manage, and I have to give permission to you, so I'm just giving you your name, and if you are the part of my group, because you are not the part of this, it's just my personal one. Otherwise, like if for all other users, it just can use it, admin can manage it. So from here itself we can manage the permissions, correct?
Okay.
Yeah.
Mhm.
This is very very interesting, and very like if we have to do any sort of like we need to connect to any of the tools like Tableau, Power BI, DPT, Python, any and many more tools are there, so we can connect them. So it has got very good a list of tools where we have to do any sort of monitorings are there, so we can set alerts, like at what time we have to set what kind of alerts we have to set. So those kind of things we can do it. Then
Okay.
we have got this marketplaces there where you can get different data sets, or other features which can be provided. So now they have on daily basis they are adding lot of things are getting added here itself, right, within the Databricks. So they are coming up with lot of changes. Then if you have to do any sort of, let's say, SQL editor, or you have to write some queries, you have to create tables, or run any SQL queries, so you can create this within the SQL editor itself. You can do it from the SQL editor, as well as like I have created this notebook I told you. So we can create do the same thing from, we can run the query from here itself. So whenever I have created a notebook, so by default it's the language is Python, it's default language. But if I want, I can change it to SQL also. Here if you see, we are only having Python and SQL, because it's again it's a limitation, right? Because here we are using only it's a free version. But if I show you here in my paid version, you see there are a lot of other things are also can be there. Now you will see all the things here itself, but in free version we don't have all the things. Come on. It's taking longer to open, right? Yeah, so I was showing it to you, like here. Okay, fine. This is also free version. I got it. This is also free version, but
Okay.
if you are using, if you are not using free version, so you will see two things: Scala and R.
Mm-hmm.
Those two
Okay.
also will see Scala and R, right? Because it's not my, this is another system. Right? Company's system where we are using. Like basically, this is another project that I'm on my own. But here also this is also the free version that we are using, right?
So you used scalar or R?
Not. We are not using Scala and R. We are mainly using, the Python itself. So let me show
Okay.
you. Here we are using, let's say, it's all SQL is there, right?
Mm-hmm.
But if you go and see, this is my another notebook.
So I have read in some of the job descriptions they want R. Is R much necessary? I have
R is another language, right?
Yes, that's what I'm asking. R we need to learn? Is it much necessary or it's fine if it is?
It depends on, like, R is mainly used for, data science peoples, right? But nowadays, like, if because R has got previously R, now R is not so popular because whatever the R was previously, R was able to some, some better libraries they were providing, but now Python is for machine learning. Python is one of the, the you can say the favorite language as of now.
Okay.
So
Yeah.
that's why 90% of the people who are working in data side or in the data science side, they are all using this Python, right? So if you see, like, I have used this Databricks help. So basically these are some utility functions which are already provided. So these can be used, and this is another function, that is Databricks utils file system dot ls, is for listing all the files. So within, if I just remove this one, a list. So this is listing all the files and directories within this root folder, right? So this is my root folder. You can also check, like, because these are some of the, the inbuilt files are there, like already given files are there. I have not created these files, but these some of the, sample files which were given by the database itself, just for the sake of, like, if you want to see the data, if you want to do some sort of, work using these files, so you can do that, right? So you see, we have got volumes, we have got workspace, and we have data mixer. So if I'm using this volume, so within basically this root folder, we are having these three folders. Okay, volumes should be there with me. So we should data sets, because volumes folder is not being created, that doesn't have any files so far. So if you see, these are the, some of the data sets which are already given within this Databricks dataset. COVID is there, readme file, R datasets, Spark, readme, adult, airlines. So these are different, data sets are there. If we want, we can use them. We can just, query them directly, and just to do some sort of starting point that we can use as a part of, our process itself. And then, like, if I have to create some sort of, data frame from the data itself, so I'm just, creating some data. So this my data contains two things: name and age. So name I have given as, so this is one, I'm creating the data frame using some row. So this is my one row, this is my another set of data, this is another set of data. 3 data sets are there. Then I have specified my schema as name and age. Then I'm specifying my, displaying my data frame. How I'm creating this data frame? So I'm passing as spark dot create data frame. So this spark is that Spark session is there. So basically, by default, as I was telling you, Spark sessions object is Spark. So this is my default object is there. That is my Spark object. And I am creating this data frame. So this is how I can create my data frame. This is one way of creating the data frame. We'll see different ways of creating the data frame. So this is one way how we are going to create data frame. So we have some data also, like from the itself we can create some data frames, right? We can read some Excel file or some CSV file, and then we are going to get the data from the data frame itself, right? So this is how we can do it. We can create our own data sets, we can create tables on top of it, and we can just query those tables. Either if we have to query table here, we can do it here using Spark SQL. So if I have to query here in the Spark SQL, I have to just write spark.sql, and within that I can also query it. Or if I'm not using Python, if I'm using Spark, so SQL, so I'm directly can call the SQL queries. Apart from this, having more important, you can say helper. This is called Genie code. So this Genie code is very good, tool, which basically you can just ask him anything. Let's say, write query to anything like right now we don't have any table. Otherwise we can ask for if I have to do some sort of query on this particular table, so how can I do that? So this basically help you, like wherever if you are facing any sort of issue, so this Genie code is basically for your help, right? So you can make use of it.
Okay.
Yeah. So where if you stuck somewhere, you find any sort of issues, so this can help you some, most of the times. Like, but if it is going to be quite, let's say some logical errors are there, so that it might not be able to help you, and it can help you, but in different way. The only thing is, like, if you are giving him it's a direct prompt, so definitely it will be able to help out. So till here, if you have any questions, any queries, please let me know.
No.
So, no queries so far?
No.
Okay, fine. So let's move on to data frames now.
So one thing I want to ask, so those permissions you showed me, right? Those permissions and all the admin will be doing, so we developers won't be doing, or is that sometimes the developer also needs to, is there any scenario that the developer also do these things?
Your voice is coming very slow. Can you just speak?
Okay. Is it audible now?
Yeah, now it seems to be fine.
So,
right?
Okay. So this permissions you showed me, right? So those works will be done by admin, or developer also needs to do those?
No. Like initially, like like permissions can be granted by the admin itself. So once you have done it, like when you are doing it by yourself, whosoever creates it automatically becomes the the admin. Like if you to someone else, if you are defined as you can define add him as admin, or you can define as can manage. So can manage permissions can be done like you can create tables on top of it, you can modify them, delete them, add them, insert, whatever, all the manage permissions can be there. Or you can, even if you want to share that file or add some other person with managed permissions or lower than managed permissions, you will be able to do it, right?
Okay. Okay. So I can, what you're telling, what I understand is, so I can even manage the permissions, is it? And I
You can
manage
also
permissions.
even manage the permission. Yeah, as I told you, like when you are creating something, or when you have created your something, so by default you becomes the admin, and admin has got all the rights.
Okay. So yeah, I got it. But basic permissions and all will be admin. I mean, initial permissions and all will be created by admin, right? Yeah. So I wanted to know what are all the permissions needed when we. So as soon as we start, we consider we start working. So
Permissions like read permission, write permission, delete permissions, or based on like the permissions that you are applying on a table, you are applying on files. So like if they are only read permissions, so you can only read, you cannot modify anything, you cannot change anything. So based on the the users, like let's say if there is some junior developer is there, whom you only want to give only read permissions, so that that person mistakenly should not delete anything, right?
yes,
Delete any
correct.
file. So for that reason, we can assign the
Only read permissions,
only read permissions, right?
not edit. Yeah, I got those things. So initially, if we are getting into the project, and then we need the access and permission. So, what we have to ask for the permission. So one, I need a read write.
Yeah, you can like
So,
if you are going to work on that, and you have to on daily basis, or like you have to do some sort of like deletions, updations to that particular file. So manage permissions will be there. But let's say for me also, there are few like I'm working on one project, another person is working on another project. But if I have to get the data for a particular table, and I just want to get the data, I just wanted to read that data, so I'll get only the read permissions. Why will I get that manage permissions?
mhm. Yeah.
So based on the the role, that's why they are called as RBACs, role based access controls.
Mm-hmm.
Based on your role, we can assign those permissions, right?
Okay.
This is generally what we used to do it, right?
What you said, R based? It's like RLS, row level securities. Eh?
Yeah, role based.
Okay.
RBACs, role based access controls.
Okay.
And another permissions are generally going to be the role based access controls plus based on the like whether they have to got the permissions like access to what label they want the permissions, uh, like catalog label, schema label. Those are those permissions we can also set.
Okay.
Okay, so let me. We can also read some sort of files. One example we have already checked, like how we are going to create the schema from the if we are having these data is already there. So let's see if I'm going. Let me change this. This is one way, and another way I can change it. Let's say I'm going to add one more column to it. So 1 comma 3 comma. Right? So I have added one more column to it, right?
Yeah.
Now here I'm going to add one more column, that is ID, right? I've created one more column ID, and this is one way that we can create it, right? Or let's say instead of schema, we can give it. Let me delete this, right? Now I'm creating a data frame with children, right, like this. And this schema, it does not need to be the same name. Let's say if I'm giving, let's say, columns. So here I'm just specify columns, or I can just give it like schema equal to columns. Schema is by default, right? And then I'm going to run this. But before running it, you have to create this, it is showing 1, 2. Okay, so now you can see we have got ID, name, and age is there. In this way also create it, and there is another way, like if you have already having some sort of files are there with you, so you can use those files as the source files, and you know let me check. Now can do some sort of operations on this file too. Let's say if I have to filter groups, I've selected this one, and I have to do some operations. Let's say I'm doing filter, so df underscore children dot select. I'm selecting ID dot using filter, and within this filter age is less than 10, right? Let's suppose. So we should get, and then we are displaying.
I'm showing.
The ID and name. But
Okay.
doesn't have age, then how to work.
Okay. Let ID is
Okay. Basically, why it is showing, because it is this one. This is another, like example, as I told you, it's all immutable, right? This DF children is storing this whole data frame where we are having all this information. But when we are filtering this data, so this DF children is still pointing to this. So what we'll do is creating one more DF filter, right? Then this see. Okay. What does this mean? Here, that's why we are calling it as immutable. Right? Basically, in Python, hash are the you have already done the Python, so hash are basically used for commenting, right? You can also do different more functions like df group equal to group by age dot count. And then you can, although the ages are different, so it's not going to do. Let me just copy this.
Oh, yeah.
Five. Okay, to do the group by and see based on age, we have grouped it. If we want to group it based on the name, just change it to name. See. Because names are, all the names are different, right? Okay, so apart from this, what all the we can do, let's say, distinct. Because we have not specified any column, so by default it is giving distinct based on the all the three columns. They are,
Okay.
you can just go through, as I told you, there are around 80 different, some transformation and external functions are there that we can check. So check out all those things. First, you need to just, sign up on this Databricks and whatever, do some hands-on, and then in the next session, we'll see like if you have any problems. Otherwise, we'll see like how we are going to read, different files, CSV file, Excel files, JSON files, Sparky files. So those kind of files we are going to use, and then we will some more, functions, and we'll see that, the differences, which file is, and
Okay.
how the different, optimizations that we can apply on top of it, right?
Okay.
Yeah. So whatever we have done today itself, if you have any questions, queries, please let me know.
Oh, sure.
So if you find any issues in going through this, just let me know. For although it's quite simple, you just need to go to Google and just click on that, that edition, right? And you free edition, this one, and then sign up. It will just ask for the the email ID, and then it will free will be there. Because it's all having all the features. The only thing is they have got certain sort of limitations on the usage itself, right? Like you cannot use for very heavy queries. Like even for, I think it is having around 500 queries that you can run on a single day. So 500 queries are very huge, right? For learning purpose, it's quite fine. Let's say you have doing some sort of, let's say, insert operation. So when you are doing the insert operation, so if it is inserting row by row, so definitely it is going to create the burden on the server itself, and sometimes it says, okay, your today's limit is over. So whenever it will come to next day, it will be done based on the the where you are basically creating it. So it will be done within 24 hours of usage. Okay. Any questions, any queries, please let me know.
Yeah. Okay. Yeah.
Fine. And also, just try to recall all those things that we have learned so far, because it should not be the case like we are going further and we are just we are ignoring the previous things, because those things will come again and again. We'll try to but you should have the idea. I know, like whatever we have learned as a part of Hadoop, those are not directly going to be used, but right now whatever we are using and we are discussing, those are directly going to be used, right? And whatever we are doing as a part, same thing you have to do in the industry itself, right? The only thing comes is, like here we are working on a smaller part of the data, and there we have to work on terabytes, petabytes, or whatever the different kinds of data that we have to work on, right? Otherwise, like whatever transformations we'll do here, the same transformations we have to do, because those are not going to change. The only going to change is the size of the data and the complexity of the the problem that we are dealing with, right? The diverse data sources which are coming here, we are going to work with 1, 2, 3 different type of data sources, but within the industry itself, it's going to become from but we'll discuss all those things with smaller set of data, right? This is the only difference.
Okay.
Yeah.
Okay. Yeah.
Okay. Anything else before we?
Please share me the notes.
Yeah. Okay. These notes I'll share with you. Within the, I'll just share in the chat itself. But this video will be, if you want that video, that will be shared by Vineet only, right?
Okay. Yeah.
Okay.
Okay. Thank you.
Thank you. Bye bye. Have a nice
Bye.
week.
You too. Thanks.